Good afternoon, everybody. Or morning, rather. Good morning, everybody. How are we all doing? Sure. All right, great. Nice to have you all around, and I'll say welcome to Web3 Lagos. All right, so this morning I'll be speaking on understanding blockchain for beginners. And when we are talking about beginners, we are not just talking about people that are entirely new to blockchain and cryptocurrencies per se. Do we have persons that are completely new? I mean, you literally, let's say you've only heard about blockchain, but you don't really know what it means. Can I see your hand up, please? Okay. All right, quite a sizable number. So that means the rest of us are pretty much familiar with what blockchain entails, right? Echo, right? All right, great. Thank you. Okay. So, however, since most of us are familiar with what it entails, I just want to let you know that this session is not just it's not strictly for beginners, but it's for every one of us because it's our duty as people within the space to tell others and share your knowledge about blockchain to other persons, and that's exactly why we are here in Web3. That's why we are here, right here in Lagos for this event, because we need to let people know what this technology entails. So, in as much as you are not a newbie, you are not a new person to blockchain, you need you need to understand the methods of how you can tell other people about blockchain. So basically, that's what we'll be considering this morning very quickly. If you have questions, I would really love to answer a lot of questions. I have limited time, but I really love to answer lots and lots of questions. So, okay, so what is blockchain? Now, the idea of a blockchain is something that is familiar to every one of us here, directly or indirectly. Why did I say it's familiar to every one of us here? The reason is that um, every one of us has seen a ledger. Are we together? Yes, the idea of a blockchain is based on the idea of a distributed ledger. So it's based what blockchain entails, or the summary of what a blockchain is a distributed ledger. All right, so a distributed ledger. So otherwise, you could refer to blockchain as a distributed ledger technology, right? So how does a ledger look like? It's simply just a book in which records of transactions are entered into. As simple as that. So just a book in which records of transactions are entered into. So now, back then, let's say 5 years ago, most especially, it was very popular at banks. When you walk into a banking hall and you make a deposit, a cash deposit to another account, to someone else's account, when you are done with that deposit, you'll be asked to enter in, details of that transaction after you are given a teller. Are we together? Who can relate what I'm saying? Yeah. After you are given that teller, you'll be asked to enter some records. Let's say the date. You'll be asked to enter the name of the depositor, the person making the deposit, the amount which you entered, But how many of us still see that in banks these days? I mean, it's literally phased out already because everything is now digital, right? Yeah, so great. So that's what blockchain actually does. Blockchain is a digital form of that. Blockchain is a digital ledger. Meaning, what is entered into a ledger? Well, everything that is entered into a ledger are transactions. Now, there's always a misconception about blockchain. People think most times the only records entered into the blockchain are financial transactions, and that's wrong. So, not just financial transactions are entered into the blockchain. Any form of transactions can go on the blockchain. It could be health records, it could be logistics and supply, it could be, in fact, anything at all. As far as it is a record, it can be entered into the blockchain. Reason why most of the transactions that occur currently on the blockchain are financial transactions. It's a wave of, after the 2007, 2008 financial crisis, other methods of, that was when fintech began, and the concept of fintech, as it were, came into being, and that in the process towards 2009, people began exploring other alternatives to the form of finance, to the traditional finance methodology which we had then. And blockchain was one of those options that were explored, and then that led to the creation of the first, reason, the first, let's say, valuable application of blockchain technology, which was in cryptocurrencies and in the creation of Bitcoin, the first cryptocurrency. Are we still together? All right, that's great. So having said that, let's continue. Let's check out some other stuff. So blockchain is a distributed ledger technology here, which allows for secure, transparent, and tamper-proof, transactions. So the difference, what that means is simply that, yeah. So I'm still on the first line there. So blockchain allows for secure, transparent, and tamper-proof transactions, meaning every transaction, most especially on a public blockchain. I'll still go into types of blockchain very quickly, but most transactions, most especially on a public blockchain, is accessible to anybody. All you just need to do to interact with the back end of the technology is that you just need to, let's say, if there's a block explorer, you just have to go on the block explorer and check whatever transaction. You get any detail you want to get. Is that noted? All right, great. So blockchain transactions are also transparent, meaning is accessible to everybody. Everybody sees what is going on. If I send, let's say an address, for instance, vitalik.eth. If vitalik.eth sends me hk.eth 5 ETH, it is public, and everybody knows that transaction occurred. Are we together? I mean, it's public, it's transparent. Nobody can deny that I did not receive 5 ETH, for instance. Are we together? Yeah, and they are also tamper-proof, meaning any transaction that has been made cannot be altered. So you cannot alter any transaction that has been made using blockchain technology. Once a transaction has been made, it cannot be altered. Once it has been confirmed on the chain, it cannot be altered. Meaning you cannot change, let's say you cannot change the value. Let's assume you sent 5 ETH, for instance. You cannot say, okay, I want to send 2 ETH. I mean, once it has been confirmed, it's confirmed. So it's tamper-proof. You cannot change values. You cannot modify it. So basically, that's what that means. Now, the next point says it's a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. Basically, we are saying the same thing. You cannot modify transactions. And that's to our benefit because let's say before the coming of blockchain technology or cryptocurrencies as a medium of payment, there are, sometimes transactions, let's say general cash transactions sometimes might have an issue of being not what's it called now, not tamper proof or not unique or not let's say it doesn't have that feature of being let's say unique. Let me just use the word unique now, in the sense that if I send this man 500,000 naira, it gets to him fine, but along the line something else might happen, and it's very possible that money may not get to him. Do you know that? Are we together? Something might happen. Have you ever sent a transaction, let's say maybe even within banks, let's say in Nigeria now, within banks, I mean, and the recipient doesn't get the transaction, and the person calls to say, let's say I sent you 200,000 naira, didn't you get it? And the person will be like, I didn't get it. I mean, it happens, right? Yeah, that doesn't happen on a blockchain. So that's one of the advantages. Once a transaction has been sent and it has been confirmed, remember I'm using the word confirmed because it has to be confirmed by a miner for it to go, for it to go through. Are we together? So once it has been confirmed, there is no dispute. There is no dispute. The person receives exact value as that has been sent. Is that noted? All right, great. So blockchain is built on a network of computers that work together to verify and secure transactions, otherwise known as, they could be validator nodes, right? So what the nodes do, they confirm, those are the nodes, nodes, basically validator nodes confirm transactions. So let's say on a blockchain, there's usually a system of confirming transactions, which is done by, let's say, a particular consensus algorithm. For instance, there are many I'll still talk a bit about consensus algorithm in other slides to come. So there is proof of authority, there's proof of stake, there is proof of work. There are many of them. Yeah. So, but the most popular is the proof of work and the proof of stake that we have for now. But there are others. All right. So the next slide now. How does blockchain work? How does blockchain work? So basically, blockchain works by creating a chain of blocks which contains a specific number of transactions. Are we still following? Yes. So a blockchain works by creating a number of blocks, right? Which contains a specific number of transactions. All right, let me go to the next point. I'll explain this together. Next point says each block has a defined block size and is linked to the previous block by a cryptographic hash. Now, blockchain is premeditated on a particular technology which is known as cryptography. Are we together? Are we together? All right, great. So now, how does cryptography? Basically, cryptography works by encryption and decryption. Encrypting simply means to conceal. That's to hide an identity or to hide something. While decryption means to reveal the identity. So how does a blockchain? Blockchain works on that technology of cryptography, meaning in order to make the blockchain and the number of transactions compact, it has to go with that method of encrypting information so that they do not become too bulky. Are we together? So that they don't become too bulky. That's one. And they don't become too burdensome to read. And that works through what is known as hashing algorithms. So there are different kinds of hashing algorithms that work on a blockchain. The most popular one, which most people know of, is the SHA 256, which Bitcoin uses as a hashing algorithm. So basically what happens is that whenever a transaction is made, the full details of the transaction may not be published on the blockchain, right? The full details may not just be published directly. So it's kind of encrypted in what is called a transaction hash. So when you pick that transaction hash and you search it, look for that transaction hash on a block explorer, you can now see all the details of that transaction. Does it make any sense? So let's say I sent Bitcoin to my brother here. Now, having sent that Bitcoin, the details of that transaction, what are the basic details that are contained in that transaction? Number one, the timestamp. Timestamp simply means when the transaction, the particular time, the hour, the minute, the second in which that transaction was made is known as a timestamp. So what's contained in that transaction? Number one, a timestamp. Number two, you also have series of other transactions, let's say a preceding transaction and a transaction that occurs post that transaction. Are we together? Yes. So all those things are contained. Now let me quickly make an example of what we mean by, we said blockchain works by what? Creating a chain of blocks. Now, can I get let's say 5 people, please? Can I get 5 people? Volunteers, please. Okay. Yeah, please just come forward, please. Thank you. Yeah, so that's 3. Please clap for them as they come forward, please. Thank you. Yes, just 5 people. Just 5 people. All right, great. So we have 4, 5. Great. Are we still together? All right, I want to ask you one question. Link your hands together, please. Yeah. All right. So let's assume this is a blockchain. Or let's say this stage is the blockchain. Can we see this stage? Yeah, let's assume this stage is the blockchain. Sorry, I want to ask you a question, sir. Please, how many wraps of fufu can you finish? 3. Oh, you can finish 3. So that 3 wraps of fufu. So now, this is a blockchain, right? I said this stage, this entire platform is the blockchain. Are we together? Yeah. So this man here is a block. A block is made up of transactions that has happened on chain. However, there's what is known as a block size, or a block size, right? This is a blockchain. Where we are standing is a blockchain. Constituents of a blockchain, a block. Now, every block has a block size. So now these 3 transactions. So this man here said he can finish 3 wraps of what? Fufu, right? So that 3 wraps signify transactions that are being made on that blockchain. However, every block, right? Remember we said, a blockchain is divided into blocks, right? So this is a block. So every block has a block size. That is the total number of, or a maximum number of transactions that a block can accept. Do we understand that? Does it make any sense? All right. So every block has a maximum size, which is known as a block size. So this man here, those fufu represent what? Transactions. So he can only accept 3 transactions. And mind you, all of them will be the same. So that means this person also accepts 3 transactions. So as soon as 3 transactions are made, a new block is created. As soon as 3 transactions are minted or made, a new block is created. As soon as 3 transactions are made, a new block is created. As soon as 3 transactions are made, a new block is created. And it continues that way. So remember I said one of the goals of that is to make the blockchain compact, right? If it was on a centralized ledger, you have to keep on storing. That's why information gets lost. Because on a centralized ledger, let's say like government ledgers, I mean, if you go back to your bank today and ask them that I made a transaction in 2007, please, I want to see it. Do you think they'll give you? What do you think? Do you think it will be readily available? I mean, the bank will tell you are stressing me. 2007, I mean, and we are in 2023. That's almost how many years ago? In fact, some banks have even folded up before then, right? Some banks have been merged, some banks have been reintegrated, changed names, changed records, changed different things. So those transactions are nearly lost. They are nearly lost. In fact, if you go to let's say your banking app now, in fact, it has a limited number of, let's say date in which you can request for your banking statement. Let's say within a span of 1 year, a bank can send you a statement of, let's say, 1 year or 2 years ago. Once it exceeds 5 years, I mean, it might nearly be impossible to get your bank statement. Does it make any sense at all? Yeah, great. So, yeah, thank you. Please clap for them, please. Thank you very much. All right, so that is how blockchain works. And remember, we said here on one of the points that it has a defined block size. I've explained that. Each of them are linked to each other. Each block is linked. When one block is complete by a particular number of transactions, it moves to the next block. So a new block is created, right? And they are all linked together by a cryptographic hash. Remember, now, have you seen some set of alphanumeric, for those that may not know what a hash is, right? Now, like I explained earlier, once I send any transaction on the blockchain, that transaction is hashed. There are different kinds of hashing algorithms, but the most popular, like I said earlier, is SHA-256. So hashing just encrypts that transaction into a single line of alphanumeric characters. That's just what hashing is. As simple as that. So it just encrypts that entire transaction, all the details of that transaction, into a single line of alphanumeric characters. So you take that, sometimes say transaction hash. Maybe you sent some money to somebody and they want to confirm. They'll say, send me your transaction hash. Let me confirm it on the blockchain. So when you send the person the transaction hash, you can now search it on the Block Explorer, and then you get details of that transaction. So it's usually an alphanumeric character, right? So when you search it on the Blockchain Explorer, it now decrypts it for you to show you the content of that. So each of those blocks are linked together by a cryptographic hash. Is that noted now? All right, and next is this means that if any data in a block is changed, the hash will also change, and the entire chain will be invalidated, meaning is nearly impossible for the hash to change, right? Every hash is unique. No 2 hashes are the same. Those alphanumeric characters, you cannot see any of them. In fact, even your addresses, your wallet addresses, no 2 are what? Exactly the same. It's possible they might be similar. Maybe the first 5, alphanumeric characters and the last maybe 3 or 5 may be the same. It's possible to get an address in which the first 5 or last 5, let's say you pick an ETH address, OX, maybe 527, you could see another OX 527, right? Yes, but no 2 addresses on the blockchain are the same. So that's what cryptography helps blockchain achieve. All right, so we move to the next slide. Benefits of blockchain. So number 1 is security. Now, remember I said blockchain is built on the basis of security. Security is one of the number 1 features that a blockchain offers. that blockchain technology offers. Security is one of the so blockchain is extremely secure due to its use of cryptography. Remember, I said cryptography is the art of encryption and decryption. So that alone helps transactions become secure. Even banks, like central banks, they make use of cryptography too. If they want to, like, conceal information or, hide some form of information, right? They make use of cryptography. So that makes it very, very extra secure. So somebody cannot just see the transaction, or if you want to hide an information and maybe it has to be decrypted, maybe by a code or by a particular number, it's only the person that you are sending it to that gets it. Even anybody that sees a transaction hash, it looks useless to the person, except you know that this is the purpose for it. Does it make any sense? All right, great. So transparency, I think I explained transparency earlier. Every transaction on a blockchain, is open to everybody. I will explain public-private blockchains because sometimes it may be confusing for newbies. So I'll get there very soon and I'll explain it. So immutability. Now, once data is recorded on the blockchain, it cannot be altered. I think I explained that already. Cost effectiveness. Blockchain can be used to reduce costs by eliminating the need for intermediaries. Do you know why when you make a transaction, let's say most especially financial transactions, how many of us have used Western Union before, or World Remit, or any of those platforms? Yeah, we have a couple of people here that have used that. Great. So let me hear from you. When you sent a transaction, who were you the person that raised your hand? Who was the person that raised your hand? Okay, you raised your hand. Great. Okay, you made use of Western Union, yeah?
Often money sent to me through to my domiciliary account. Let me say $100, 200. Yeah.
So what was
Nothing. Yes, but why? No, no, no. It doesn't charge anything. No. Okay, they're trying to send down. Not, like I said, I'm the one receiving.
Okay, who has used Western Union or any of those platforms to make a transaction? Around $7, right? Per word for $100. That's great. So that's how many percent? 7%. Don't you think it's much? It doesn't look much because you said $100. If you are charged 7% of $10,000, that's how much? $700. So that's one of the advantages of blockchain. I mean, I don't think there's any blockchain that charges, not the blockchain charging now, or any blockchain that has its transaction fees, or let's say the miners charging a transaction fee of up to 7%. Right? Yes. So that's one of the advantages that was outlined in that place. So basically, yes, cost effectiveness. Blockchain sending transactions via blockchains is very cost effective. One of the reasons as well is that there is no intermediary. So on the blockchain, let's say you are using any of those platforms. If I'm sending money to my to my Oga here, if I'm sending money to him, if I'm using any of those platforms, right, the money does not go directly first to him. Number one, the government of the country you are sending it out of has to verify those transactions. That means the sender has to be KYC verified or KYC compliant. I'm not saying KYC is a bad thing, but those are just some of the bottlenecks involved. Are we together? All right. So the sender has to be KYC verified. The receiver, well, might have to be KYC verified or not. In fact, you have to be, because even if you don't own a bank account, if you are sent money through Western Union, you can go to any of the commercial banks to cash it out, right? And when you get there, they will tell you to submit either your workplace identification, you have to fill in your name, fill in any of those details before you can get the money. So you don't just go there and collect it just like that. You have to submit a valid ID card. Are we together? Yes. So those are some of the, but if I'm sending a transaction on the blockchain, if I'm sending this man transaction, it gets to him directly and almost instantly. Almost instantly. When we get to the next slide, I'll explain what TPS means, transactions per second. So some blockchains have a specified number of transactions per second they can make, right? All right. So scalability. Now, scalability is one of the major issues that is faced with most blockchains today. What is scalability? Scalability simply means how effective a blockchain can be over the span of time. How effective a blockchain can be over a span of time. Now, let me give you an example. I bought my first Bitcoin January 25th, 2017. That's when I bought my first Bitcoin, 5,000 naira worth. So when I bought Bitcoin then, in fact, it was very fast. Sending Bitcoin, yeah, even now too is fast. I mean, relatively, but then it was way, 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 way faster. I mean, if you send Bitcoin, it almost reflects, like almost immediately, right? And the fees charged by miners then were relatively low compared to now. So that is to say, Bitcoin is not scaling. Scaling means if you are sending, if I'm sending, like, I mean, there's some form of some form of constancy on that blockchain. That's just what scalability means. I mean, if I'm sending you let's say 5 ETH, I sent it to you yesterday. You know, in as much as more transactions are coming, number one, the blockchain does not get slower. Are we together? And by extension, what leads to high fees? You know, sorry, but I just need you to understand what leads to high fees. Can anybody, let's say high fees charged by miners on the blockchain? Can anybody answer that? What leads to that? Yeah, great. Thank you very much. Yes, volume. When there's congestion on a blockchain, what happens? You know, there are lots of pending transactions. Pending transactions. What happens? Miners will start charging higher, you know, fees to easily process transactions. I mean, there's kind of like a gas bidding, a gas war. It is referred to as a gas war, right? So whoever pays the highest fees, right? It's not as if you choose to pay a lower fee, your transaction will not get processed. The only thing is going to take a lot of time, right? So if you are buoyant enough to pay the highest fees or whatever the miners decide to set, you know, as the average gas fee for that period, your transactions get processed. Are we together? So those things are caused because when there is congestion on a blockchain, right? So those are some of the problems with blockchain to scalability. So there are more blockchains like Ethereum, you know, that are really working on these things, you know, trying to scale, you know, and doing all this. So that's for that. So, but largely blockchain is highly scalable because when you consider the number of transactions that occur on blockchains per day, I mean, there are a huge number. Sincerely, some fintechs may not be able to handle that. So blockchain is a much more effective way of having transactions. All right. So applications of blockchain. Yeah, blockchain is used in finance, and that was the first and most practical way in which blockchain was first used in finance. You know, how does it work in finance? You create secure and transparent financial systems. Now, a very good example of that is CBDCs, right? CBDCs are not actually bad. Are we together? Yes. But the difference between a CBDCs are built on what is known as a private blockchain. Are we together? So CBDCs are built on a private blockchain, unlike, let's say, Ethereum that is built on a public blockchain where everybody can go to verify. In as much as CBDCs make use of blockchain technology or distributed ledger technology, it doesn't mean an average citizen can just go to the records and just, you know, search, okay, how much was sent from Ministry of Finance to Ministry of Agric today. You can't do that, right? It's only the government officials, a selected few, that have access to that. So that's, you know, a private blockchain, right? Yeah, the only difference is that any transaction that is now made, you know, is immutable, right? It's immutable. However, not everybody can access it. That's why it's not known as a public blockchain. All right, that's that. So you can use it to create secure and transparent financial systems, even for government in the idea of a CBDC, and for private individuals, even within a company, you can create a private blockchain that is just accessible to your company alone. Are we together? Yes. So that's that. So transactions, most especially financial transactions, are transparent. Now, in supply chain, you can use the blockchain to track movement of goods and services or whatever, logistics. Yeah. Maybe you are moving something from Kano to Lagos. I mean, you can check when. It's just like something related to, let's say, 17 track engine. Some of us use that, let's say, to track, let's say you are getting a match from outside the country. You have to know, okay, when is it going to land in Nigeria? When is it going to be here? And like that. So you can use that, to track supply of logistics and those other things. Now we also have we also have healthcare. Now, health records, how many of us have been pissed? Because I'm always giving examples because these are practical issues we can relate with, most especially in Africa. Are we together? And by extension, the rest of the world. Yeah. So, how many of us have gone to a hospital before, and it takes them forever to bring out your medical records? It literally takes forever. I mean, you'll be tired of waiting. They tell you wait and wait and wait and wait until the whole day is gone. I mean, it doesn't make any sense. However, on a blockchain, if you have your records, your medical records on the blockchain, I mean, once you get to the hospital, all you just need to do is just a cryptographic something, cryptographic hash, maybe like a wallet address or something. You just provide it to the doctor, okay, and the doctor is able to access all your past medical history, and like that, and enter in new records, maybe for the condition you are facing at the moment. Once he enters in new record, it's already on the blockchain, and it cannot be modified or removed. Yeah, so another doctor, another time, it's easy to access your past medical records. So it's very, very useful in healthcare. So yeah, government. I think I already made mention the use of what government can ways in which the government can apply blockchain technology. I mentioned CBDC, and now I'm mention so now in transparent voting systems. Now you can make use of blockchain for transparent and more democratized voting. In fact, I think there are some companies in Nigeria working on that at the moment, or have even worked on that. Systems on the blockchain which you can use to vote. A very good example of that in some ways is a DAO, right? How many of us have an idea of a DAO? Right. So government too could pick up that kind of structure for the entire nation, and they are able to vote at the time of election. Yeah, so that's that. Then others, we have that blockchain is being explored for a wide range of other applications, including real estate, intellectual property, internet of things, and like that. Yes, there are lots of ways in which blockchain can be utilized. Basically, you just need to understand that blockchain can be utilized for a system that is decentralized and distributed. That means everybody has access to it, equal access to it, and is not controlled by a central authority. All right. So very quickly now, terminologies and FAQs. Now there are very common terminologies in blockchain technology that might not be so familiar to newbies. So I'll just explain them very quickly. Scalability. I already explained scalability. So let me just throw more light on that. What is scalability? Scalability simply refers to how efficient a blockchain can be over a period of time. Over a period of time. Now, how many of us heard about a blockchain like that? I would not mention name. That at a point in time, it was as if the blockchain was literally halted. Right? Yes. I would not mention name. All right. Thank you. So that is to say, at that point in time, the blockchain was literally unscalable. So it was not so at the beginning. Now, when a blockchain is created, at that instance when it is created, it is very much scalable. Most blockchains, very much scalable, in that once you make a transaction, I mean, everything just moves very, very, very efficient. However, as more people come into the system, as more transactions are made on the system, sometimes you notice that there will be things like congestion on the blockchain. The blockchain starts getting congested. There will be other issues like that, with the system. So those issues sometimes make a blockchain not scalable, and it has to be improved on, in order to make it more efficient or scalable. That's just what scalability means. So TPS stands for transactions per second. Remember, I told you that every blockchain has a block size, right? You remember that analogy, right? Yeah. So every blockchain has a block size. Also, every blockchain has a maximum number of transactions it can perform per second. In fact, this does not apply to just blockchains alone. It applies to even like fintech apps. For instance, Visa. I think for now, Visa is the fastest on earth. The fastest Visa is the fastest, should I say, financial solution or infrastructure with the highest TPS. transactions per second. So Visa can process, I think, I'm not really sure of that, maybe about 500,000 transactions per second. Are we together? So blockchains also have what is known as transactions per second. So some blockchains can process, let's say, 50,000 transactions per second, 200,000 transactions per second, and like that. So it's also known as throughput sometimes too, you know. Now, issue of double spending. Yeah, these are some of the things. Now, let me give a very quick illustration on what double spending is all about. So now, on the blockchain, sometimes some people think, let me use that word think, even me, I've tried to like try it out before, you know. I love doing experiments. So initially when I started interacting with blockchain, I'll be like, wow, if I send a transaction, let's say on Ethereum now, you know, there was a time the Ethereum blockchain was very much congested, right? And let's say I send a transaction and it will be pending, right? It would be pending. Let's say it has, maybe I don't want to pay the particular gas fees the miners are requiring that I pay. So it's going to be pending for quite some time until it gets sent. However, the period in which it is pending, the transaction will still be the value, the, let's say, dollar value or whatsoever, will still be reflecting in your wallet. Am I right? I mean, as far as the transaction is not sent, the transaction, the what's it called? The value. Let me take it this way. Let's say you have 5 ETH in your wallet. You open your MetaMask, you have 5 ETH. Now you send out 2 ETH to a friend. As far as that transaction is not confirmed, it's still going to reflect on your wallet that you still have what, 5 ETH. Are we together? So you may think you can cheat the system, or so I thought that I could cheat the system, you know. And immediately I sent that transaction. I'll try sending another 2 ETH to somebody while that transaction is still pending. Does it make any sense? Yes, so that you think, okay, two ETH go to this person, two go you grab. Or let's say you're even left to just 2 ETH in your wallet, and you try sending to two people at the same time. It would look as if it's actually sending, because one has not actually left your wallet. So two transactions will be created. I'm explaining double spending now. So two transactions of 2 ETH to the first person, 2 ETH to the second person, two transactions will be created. However, at the end of the day, only one will be sent, the other will be cancelled. Do you understand? So one will be sent, the other automatically will be cancelled. So that is the way blockchain helps to prevent double spending. So you cannot double spend on a blockchain. One will definitely go through, even if it's the same transaction you are trying to process. As far as that is why it incorporates cryptography. You know, the basis of blockchain is cryptography. So, you know, every transaction will always have different transaction hashes. So as far as the transaction hashes are not the same, the nonce is not the same, and all those things are not the same, only one will be processed and the other will be reverted. Yeah, so that's also blockchain solves double spending. So types of blockchain, yeah, I mentioned I was going to explain types of blockchain. So we have, the most popular is the public blockchain, right? Yeah, so we have public blockchain. So how do public blockchains examples? Bitcoin, Ethereum. I mean, anybody and everybody can access, you know, or have access to any transactions that have occurred. You can go to Bitcoin and check when the Genesis block was. That's the first block that was ever created on the Bitcoin blockchain, right? All those, because it's public to everybody. Anybody can do that. So that's a public blockchain. So anybody can access information. Remember, it's records that are stored on that blockchain, right? So anybody can access records that have been stored on that blockchain. So that's one. So we also have private blockchains. So like I said, private blockchains most times are just restricted to a couple of persons. Yeah, let's say it could be for an organization and they just want to have their what was it called, maybe records of, maybe health records or whatsoever. So they just have it within that organization. So some people will be signatories to that particular blockchain. That means they have maybe a right to access information or records on that blockchain. So that's one. So that's two. So then thirdly, we have consortium blockchains. You know, consortium blockchains are also known as federated blockchains, and it works similarly to private blockchains in that you can have a couple of persons, let's say 2, 3, 4 persons having access to that particular blockchain, right? So basically, those are the three types of blockchain we have. We also have consensus algorithms. So basically, consensus algorithms are just how transactions, let's say set of logic or set of rules that are created to govern how transactions work on a blockchain, on a particular blockchain. For instance, on Bitcoin, we have proof of work consensus algorithm, right? So basically, and that works with the use of miners. So people, decide to run a node, a Bitcoin node, so that they are able to, validate transactions on the blockchain, right? So let's take Ethereum, for instance. At the moment, Ethereum runs a proof of stake consensus algorithm, right? Initially, it used to be a proof of work consensus algorithm. Later on, it was switched to a proof of stake, right? And for a proof of work now, proof of work is not really energy. It's not energy efficient, right? It consumes lots of energy and electricity. Are we together? So how does it work? You have to anybody that wants to run a node, right? On Bitcoin, for instance. Back then, there's what they call mining rigs. They are not really popular again. Yeah, mining rigs. So you hear people saying, I want to mine Bitcoin, right? So in order to run a node, you would have to, if it's under the proof of work, you'd have to buy those bare metals, right? Those hardware machineries, and those, mining rigs, those fans and stuff, you connect them to your PC, and you need to have 247 electricity, and you run it, and like that, you are able to validate transactions on the blockchain, right? However, in proof of stake, you have less people doing that kind of work. So the bulk of the people, what they do is basically just to stake in a pool, right? And the minimum requirement, let's say for Ethereum now, is 32 ETH, right? So if you want to stake on the Ethereum blockchain, let's say as a validator to validate transactions, you need at least 32 ETH, right? So once you have that 32 ETH, you can stake in a pool, and then you can earn fees, right, that are paid by users of the blockchain. Does it make any sense? Yeah. So basically, those are the two major kinds of consensus algorithms that we have. So let me move to the conclusion. Yes. So blockchain is a powerful new technology with the potential to revolutionize a wide range of industries. Like I mentioned earlier, in fact, blockchain is applicable in almost every aspect of life. Blockchain is applicable in almost every aspect, in health, in logistics, in education, in every aspect. There is an application for blockchain technology. So as you're in this conference, ensure you open your mind to see how you can make use of blockchain technology in whatever sphere of influence you are. Yeah, and blockchain is still in its early stages of development. It has the potential to change the way we live and work. Most especially for us as Africans. Blockchain is not like I always mention and tell people, blockchain for us is not a luxury. Are we together? It's a necessity. It's something that has literally transformed our lives. Are we together? Yeah. So blockchain is very, very much applicable. Yeah. Thank you for listening. Even though I still have something else. Okay. Yeah. So if you have any questions, yeah, I'd love to get them, and you can connect with me on Twitter or X rather, and LinkedIn. Thank you very much.